Well, hello everyone. We are going to start today our second chapter, which is called light. I know that you have some information about light from the previous years, but we are going to talk about light in more details, okay? So, what's meant by wave? I told you before that wave is a disturbance that propagates energy along the direction of propagation. Today we are going to talk about type of wave which is called electromagnetic wave and concentrated in light. Okay, you know that the light is the most renewable important source for us, as it helps plants in photosynthesis process. It gives us heat. It gives us the most important renewable resource of energy in our daily life. Okay, uh, light is an electromagnetic wave. An electromagnetic wave, you know, it's a wave which don't need a medium to propagate. Okay, electromagnetic wave, its meaning comes from its construction or its components. It consists of electric field and magnetic field. Okay, so we can call it electromagnetic. We cannot find electric field only or magnetic field only. If there is a magnetic field, it must be combined by a magnetic field and vice versa. Okay, electric field and magnetic field are always normal to each other. Okay, and their direction of propagation or their direction of motion is normal to both of them. Okay, we have two types of waves. Light, we can see it by our naked eye, and a type of light that we cannot see it by our naked eye. Okay, all of the electromagnetic wave form a group or form a group, okay, called electromagnetic spectrum. Okay, electromagnetic spectrum is an arrangement of electromagnetic wave according to their wavelengths or frequency. Okay, the following arrangement is from the biggest wavelength to the lowest wavelength, or from the lowest frequency to the highest frequency. Okay, number one, radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma rays. Okay, this arrangement is very important. Okay, the properties of electromagnetic wave are they don't need medium to propagate. They are transverse wave, which consists of crusts and troughs, move with constant speed in space, which is equal 3 times 10 power 8 meter per second, and have the ability to penetrate medium. Okay, the first property of any wave is reflection. Okay, any wave must reflect, must refract, must interfere, and must diffract. Okay, this is our topics in this chapter, and we're going to talk about every topic in details. Number one, light reflection. Light reflection means changing in the direction of the light ray but keeping the speed constant, okay, as it occurs in one medium, and you know that same medium means same speed. So the light reflection means it is the rebounding back of a light ray when it falls on a reflecting surface. When a light ray falls on any reflecting surface, it will rebounding back. Okay, so we have laws of reflection, constants in reflection. Number one, angle of incidence equal the angle of reflection. This is the first law. The second law, incident ray, reflected ray, and the normal to the surface are lying on the same plane and normal to the reflecting surface. Okay, if you want to make light reflection, you must have two things. Number one, reflecting source. Number two, reflecting surface, sorry. Number two, light source. Okay, the angle of incidence, you know before that it is the angle between the incident ray and normal to the reflecting surface. This is very important. And the angle of reflection, it is the angle between the reflected ray and normal to the surface. Okay, we have a special case when the light falls normally to the surface, okay, or parallel to the normal to the surface, it will reflect on itself. So the angle of incidence become equal to the angle of reflection equal 0. The second property is light refraction. Refraction means changing in the direction of light and also changing in the speed of light as it occurs between two different media in their optical density. Okay? If we put the pen in a glass of water, you found that its direction will deviate it in a certain direction as it light transfer from one medium to another different medium in optical density. Okay? Okay. Laws of refraction. Number 1, the incident ray, refracted ray, and normal to the surface are lying on the same plane, okay, and normal to the reflecting surface. Okay, we have very important expression in refraction called relative refractive index. Relative refractive index. It is a value which indicates the refraction of the light between two different media. Okay, so it is the ratio between the sine of angle of incidence in the first medium and sine of angle of refraction in the second medium. Okay, sine phi refers to the angle of incidence over sine theta, and theta refers to the angle of refraction. Or it's the ratio between velocity of light in the first medium to that in second medium, v1 over v2. Or it is the ratio between the wavelength of light in first medium to that in second medium. Okay, wavelength 1, lambda 1 over wavelength 2 or lambda 2. Okay, optical density means it is the ability of the medium to refract the light ray. If we have two medium 1 refract the light by a very huge angle, and medium 2 refract the light by a very small angle. So medium 1 called it's said to be it has high optical density, and medium 2 has low optical density. Okay, when the light travels from less dense to more dense medium, medium of low density to the medium of high density, the velocity will decrease, of course, and the angle of incidence becomes smaller than the angle of refraction. Phi becomes smaller than theta, and light will bend away from the normal. It will travel away from the normal in the second medium. But if the light travels from more dense to the less dense medium, the velocity will increase, okay, and the angle of incidence become greater than the angle of refraction, of course, and the light ray will bend toward the normal of the surface. Okay, and I want you to know that the relative refractive index between two media is a constant value. We cannot change its value whether we change the angle of incidence. The angle of incidence change, the angle of refraction will also change, so the sign of each angle will change to keep the relative refractive index is constant. Okay, well, that's for today. I'm hoping you're studying well. Thank you and goodbye.